Hey guys, so this is my unit plan for Education 361. I intend for it to be second grade. It is my engineering design unit, so I plan to have it at the end of the year, which will be about springtime. I have 6 lessons over 7 days because I anticipate that one of the lessons will have 2 parts to it, and I want to spread this out over 2 weeks. And each lesson will be about 30 to 45 minutes. The goals for this unit is that students will work in pairs to discover how catapults work. Working with a partner, students will create their own catapult that will be able to launch an object at least 3 feet, and students will reflect on how variations of their catapult could result in a different outcome, focusing on what worked and what did not. The phenomenon that I've chosen for this engineering design unit is catapults, and students will be exploring catapults, what they are, how they function, and how they best perform. The driving question for this unit is how does a catapult work and how do the separate parts affect its ability to function? So I have 6 lessons. The first is an introduction using Pear Deck, where students will work with a partner to draw a model of what they think a catapult looks like and how it works, just like the basic logistics so that I know where their level of understanding is at. The next 3 lessons are all my activity lessons, going off of the ambitious science teaching practice number 3. The lesson number 2 is angle of launch, so they will be throwing a tennis ball from a variety of angles to determine which angle resulted in the greatest distance. Lesson 3 will be the weight of objects and how the weight affects how far it goes. Lesson 4 will be stretch of the spring, which will have students looking at rubber bands in different sizes and thicknesses to see how that affects the tension of the catapult. So those 3 lessons are all on my summary table, which I will briefly go through. So lesson 2, students will be outside, hopefully, because it will be during the spring. I hope that the weather is nice enough. If not, they can just be in the gym. But they will be outside throwing tennis balls. They will realize that 0 degrees, which is up by their head, will drop straight to the ground. 180 degrees, which will be all the way down by their side, to go all the way up by their head. Results in the ball going really high up, but then dropping straight down, not really getting any horizontal distance. When the angle is greater than 90 degrees, which will be closer to the ground, the ball will go farther up in the air than it does forward, and that when it is less than 90 degrees, so closer to the head, the ball will go further forward than it does up, and that somewhere around 45 degrees is where the ball should travel the farthest distance. So what does this mean? When the angle is bigger than 45 degrees, it has too much upward momentum and does not travel very far. When the angle is too small, there's barely any upward momentum, so gravity acts really fast and pulls the ball down very quickly. And at 45 degrees, the ball has enough upwards momentum to combat gravity for at least a little bit, at least not combat it, but to overcome it so that it can get an upward projection and still travel very far. So the best angle to launch an object is at 45 degrees, which means that their straining rope needs to pull the arm of the catapult down to a 45-degree angle. Lesson 3, launching different weighted objects. Students will be working with themselves using a plastic spoon to launch objects like a marshmallow, a penny, a marble, a cotton ball, a ping pong ball, and a rubber bouncy ball. They will be facing the wall so they don't hit each other. I plan that out. I don't want them hitting each other. And they will have a yardstick in between themselves and the wall to help them measure how far each object goes. And they will realize that the lightest and the heaviest objects, so most likely the rubber bouncy ball and the cotton ball marshmallow, will not go very far, but then the middleweight objects like the penny and the marble will go the furthest. And that it is also hard to keep the heavier objects in the spoon because they keep wanting to like roll out or fall out. And that hopefully the marble will go the furthest, either the marble or the penny, but I believe that the marble will go further because of its shape. And that what does it mean? Objects of all weights have the same acceleration because they're not launching them at different speeds or with different force, so that is the weight that affected the distance in this activity, and that there's a parabolic shape when it comes to object weight and distance traveled. So for catapults, it's kind of like Goldilocks. It can't be too light, can't be too heavy. It needs to be just the right amount of weight, which also really depends on the size of your catapult, and that the bucket which holds the object, so that would be the head of the spoon in this activity, it needs to be big enough to hold the object to ensure that it won't fall out. Lesson 4, which is on stretching rubber bands. They will be given rubber bands that are really thick, really skinny, really small and tiny, and really big, and they will realize that the skinny rubber bands were easier to stretch than the thicker ones, so the thicker ones had more tension, and that the bigger rubber bands, they seemed like they were already stretched out, so those are a lot easier to stretch than the smaller ones, and that there's a lot more tension in the thicker rubber bands and the smaller rubber bands, and that for catapults, you want a rubber band, well, the rubber band is acting as a spring in a catapult, so the spring or the rubber band to be thicker and smaller, because that will create more tension, which will kind of be, once the object is released, that tension will pull the arm of the catapult at a much faster rate. And so students also want to make sure that it's not too small and too thick where it snaps, because that is a possibility. So you kind of have to find the amount where it can be stretched without snapping. So then back to my remaining 2 lessons. Lesson 5, the students will actually be building a catapult with a partner, and I will give them directions, but not a lot, because I want them to use what they have already learned throughout the unit to figure out the angle, the materials, kind of the structure. Well, I'll tell them the structure so that they know what it should look like in the end, but they're going to decide the object, the and thus the weight of the object, the angle, and then like the stretchiness of the spring, which will be a rubber band. And then lesson 6, I'm going to go back to Pear Deck, and they will look at their models from the beginning of the unit to make edits to kind of figure out why that model wouldn't have worked or would have worked. And then a couple of anticipated challenges. I think that staying focused will definitely be a challenge, because even myself, when I was creating this unit plan, I was getting excited because catapults are fun. You get to launch stuff. Who doesn't love to like launch things into the air, especially in school when you're always told you can't throw things and now you can? They're gonna get excited, but it's important that they stay on task and stay focused on the activity or the lesson at hand. And then building the actual catapult, I think, will also be a challenge, because while they will be given directions of, like the frame of the catapult, which I think it kind of needs to be the same across all students so that their catapult works and it's able to stand and function at least a little bit. I'm not going to give them step-by-step instructions, so they might struggle, they might get off task. So I think that will be a struggle area, which is why the building of the catapult, so my lesson 5, I plan on taking 2 days. So one day they can really focus on building it, and then the next day they can focus on testing it and comparing it with another group's. And that is my unit.